Okay, so I've been using 95% confidence interval. I've been saying that. What does that actually mean? So, as with hypothesis tests, confidence intervals are not perfect. I mean, sometimes by random chance, we'll get a bad answer. And generally, assuming everything is all the conditions have been met, about 1 out of every 20 properly constructed 95% confidence intervals will fail to capture the parameter of interest. That is, so if you do something 20 times, 95% of the time, you'll capture the parameter. About 5% of the time, you won't. So, for example, this is another one of those Ross-Machance apps. But I'm going to go ahead and ask it to do 20 confidence intervals based at 95% confidence interval. So, a sample. And you see in this case, think of this vertical bar here as the true value. These little horizontal green lines are all confidence intervals. The red ones are the ones that missed. So all the green ones touch that vertical line. This one here, and there's one down here, missed. So out of the 20, I end up with 18 out of 20 touched that vertical line, 2 did not, so about 90%. Let me reset it, try again. And this time I end up with 19 out of 20, which is 95%. If I did this a lot of times, so let's say they do 200 of them. In this case, you see the running total right here, about 94.5% are green. These red ones are the ones that missed. So that occurred about 5.5% of the time. So that's what I mean by 95% confident, is that when I do a confidence interval, assuming everything meets the conditions, 95% of the time, my random sample will capture the true parameter. 5% of the time, even if I do everything right, I may get a bad answer. Okay. So, this figure here shows 20 confidence intervals for the proportion that were constructed from simulations, where the true proportion was 0.5. However, one of these, namely this one right here, does not touch the bar. So in the figure, one interval does not. Does that mean there is a problem with how the simulations were run? And the answer is no. I mean, again, what 95% confidence means is that 5% of the time we're going to miss. So no, 95% were correct. That's what came out here. So if you want to be very certain you capture the population parameter, should you use a wider interval or a smaller interval? Well, if you think back to the fish, if you want to be really certain, you're going to need a wider interval, a wider net. So to be more confident that we have captured the population parameter, we want a wider interval. So going back to Ross-Machance, the way we do wider intervals is we raise the confidence level. And now it's almost entirely green.